Hello, E-Block. We are going to look at one more section in this unit. This section has nothing to do with differential equations nor inverse trig functions. I just need some place to put it. We're going to actually go all the way back to limits and talk about something called L'Hopital's rule. And this rule I'm about to give you will let us deal with some limits that we previously wouldn't have been able to deal with. So L'Hopital's rule, named after the French mathematician who came up with this. Returning to limits. You know that we start any limit problem by just plugging in the number. We always start by just plugging in the number. Returning to limits, we always start by just plugging in the number. And there are several different things we could get. We could get a number over a number. We could get 3 over 5. In which case, well, that's my answer. We could get 0 over a number. In which case, my answer is 0. Well, that's a pretty bad number sign. Well, you know it means number down there. We could get a number over 0. And we saw when that happened, that those were the cases where we got either infinity or negative infinity, or if it's an overall limit and the two were different, it would not exist. These three are called determinate forms because the form that we're in determines what our answer is. It's either just the number, it's 0, infinity, negative infinity does not exist. These are called determinate forms. The form determines what the answer. However, we could also get something like 0 over 0. Or we could get infinity over infinity. When you have 0 over 0, the answer might be 0. It might be infinity. It might be 3/5. It might be 2/7. It could be really anything. We call these two indeterminate forms. These are what we call indeterminate forms, which really means the limit could end up being any number. I'm going to make the video pause so you can make sure all of that stuff is in your notes. So, we saw different ways for dealing with 0 over 0 and infinity over infinity back in chapter 1. Factor and cancel, rationalize the numerator, use our special trig limits, if you remember what those are, and all that stuff. But there's a rule that will let us take care of any limit in these forms. And I couldn't have taught this to you back in Unit 1 because you wouldn't have understood some of the math behind it, but now I think we will. This rule is called L'Hopital's rule. Given the limits as x approaches c of f of x over g of x. If I want to find a limit of a ratio of two functions, if the limit as x approaches c of the numerator equals 0 and the limit as x approaches c of the denominator equals 0, which means I'd have that indeterminate form of 0 over 0. Or, still on the screen? I think I'm still on the screen. If the limit as x approaches c of the numerator equals either positive or negative infinity, and the limit as x approaches c of the denominator equals positive or negative infinity. Then, the limit as x approaches c of f of x over g of x equals the limit as x approaches c of f prime of x over g prime of x. If I have something in the indeterminate form 0 over 0 or infinity over infinity, then the limit as x approaches c of f of x over g of x equals the limit as x approaches c of the derivative of the top over the derivative of the bottom. This is not quotient rule. I'm not doing quotient rule or anything like that here. But I'm taking the derivative of the top, the derivative of the bottom, and that limit will have the same value. Why? We're going to save that for a little later. I want to make sure we see how to use this and some of the notation that we need to use when we're using this. Then, when I'm back in class, I'll show you where this comes from. First example, I want to do the limit as x approaches 2 of x minus 2 over x squared minus 4. You're going to start this the same way we start any limit problem. You're going to plug in, and when you plug in 2, you get 0, and when you plug in 2 to the bottom, 4 minus 4, you get 0, which means I'm in that indeterminate form that I can use L'Hopital's rule for. However, the AP exam is going to require you to actually go through stating the requirements of this theorem, stating that the limit of the top is 0 and stating that the limit of the bottom is 0. We can call our form 0 over 0, but it's not okay to actually say this limit is 0 over 0 or something like that. It's a technical thing, but they are very picky on this. So what I'm going to write is since the limit as x approaches 2 of x minus 2 equals 2 minus 2 equals 0, and the limit as x approaches 2 of x squared minus 4 equals 2 squared minus 4, 4 minus 4 equals 0, because both the limit of the top and the limit of the bottom equals 0. Then, what am I about to use? I'm about to use L'Hopital's rule, and I need to state it. By L'Hopital's rule, the limit as x approaches 2 of x minus 2 over x squared minus 4 equals the limit as x approaches 2. L'Hopital's rule says I can do the derivative of the top and the derivative of the bottom. The derivative of the top, the derivative of x minus 2, that's 1. The derivative of the bottom, that's 2x minus 0. What am I going to do now? I'm going to plug in my number. I'm going to get 1 over 2 times 2. I'm going to get 1 over 4. That's my limit, and this is L'Hopital's rule. And this is how you're going to need to write things out. Because they're picky about this, I need to be picky about this as well. Now, you were probably looking at this problem and thinking, well, I already know how to do that. We could just factor and cancel. Of course you could. You could just factor and cancel. And you would say that original limit is the limit as x approaches 2 of x minus 2 over x squared minus 4. That's the limit as x approaches 2 of x minus 2 over x minus 2x plus 4. Those minus 2's are going to cancel. This is the limit as x approaches 2 of 1 over x plus 2. That's 1 over 2 plus 2, that's 1 over 4. It's the same answer, and I think this is easier to do factoring and canceling. The reason this rule is going to be particularly helpful is for problems where we can't use those, honestly, very few limit rules that I already gave you. So let me show you another one. Let's take a look at this. Let's do the limit as x approaches 0 of e to the 2x minus 1 over x. And I'm going to plug in. And I'm going to get e to the 0 minus 1. 1 minus 1, that's 0 over 0. So, yep, I'm allowed to use this new L'Hopital's rule. Now you should be able to look at this, I hope, and realize factor and cancel is not going to do anything for you. Rationalize the numerator is not going to do anything. Our special trig limits aren't going to do anything. The only way we can handle this limit is by our new L'Hopital's rule. Since, you know what? How about you see what you can do here? See if you can write out the requirements and then say by L'Hopital's rule and see if you can apply it. To that, as x approaches 0 of e to the 2x minus 1. What am I doing? I don't know what I'm doing. I'm tired. I'm done. Limit as x approaches 0 of e to the 2x minus 1 over x equals... Okay. The derivative of the top, derivative of e to the 2x is e to the 2x. But by chain rule times 2, derivative of minus 1 is 0. Derivative of x is 1. Plug in? Absolutely. 2e to the 0 over 1, you're going to get 2. Your limit is 2. Hopefully by now my meeting is over and I am back in class. And if not, you are going to find something to work on until I'm back in the room. I will hopefully see you very, very soon.